This is a video lesson for both Lesson 7 and 8. Lesson 7 and 8 have the same learning target, which is I can use the area model and multiplication to show the equivalence of two fractions. So we're going to be building upon our learning from Lessons 5 and 6 of showing equivalence fractions, but this time we're going to be using multiplication. So a lot of you will probably find this way of finding equivalent fractions a lot quicker and easier, but let's go ahead and take a look. So in the first problem here, we're going to be taking a look at finding some equivalent fractions first with the area model and then explaining how we can find them also with multiplication. So I'm going to start by looking at 1/3, and I'm going to be doing the same thing to both here to show that we have the same amount here. So we both have 1/3 right now shaded on both. But on the second area model here, I am going to split it in half, kind of like we did in Lessons 5 and 6. So if we go over to our first area model, we see that there was one part that was shaded in. That was right here. And there are 1, 2, 3 parts total. So we get 1/3. In the second area model that we split in half horizontally, we see now that we have 1, 2 parts shaded in red. And then we have 1, 2, 3, 4, 5, 6 parts total in the whole area model. And so we see that 2/6 is equal to 1/3 because the size of the shaded region didn't actually change. It didn't actually go in and shade anything extra. So we see that even though we have more parts shaded and more parts total, that we have the exact same amount because the parts themselves are smaller. So there's less parts shaded in here and less parts total here, but they're bigger pieces, as you can see. So to show this equivalence with multiplication, you might have noticed that the number of parts shaded from 1/3 to 2/6 doubled. So it was multiplied by 2. And then if you're paying extra close attention, you also might have noticed that the number of parts total doubled, so multiplied by 2. So with a multiplication sentence, we could write out that 1/3 is equal to 1 times 2 over 3 times 2. And we solve the multiplication on top first. 1 times 2 is 2. And then on bottom second, 3 times 2 is 6. And so we solve with multiplication right here that 1/3 is equal to 2/6 as long as we multiply the top and the bottom, the numerator and the denominator, by the same number, which in this case was 2. So let's take a look at another example here. This time we're going to move away from unit fractions and we're going to look at some non-unit fractions. And even though they're a little bit more challenging, we're still going to follow the same process. So once again, I'm going to fill in a fraction on both of the tape diagrams here. So I'm going to use 2/3 for this one. Except for this time, rather than splitting the second tape diagram in half, to show the equivalence, I'm going to zoom out just a little bit here. There we go. So to show an equivalent fraction for 2/3, which we have represented in this first area model, I'm actually going to split this other tape diagram into 4 parts horizontally. Doing my best to draw my straightest lines possible. And so now you see that I have 1, 2, 3, 4, 5, 6, 7, 8 parts shaded in. So that's my numerator. And there's 9, 10, 11, 12 parts total. So I showed with the area model that 2/3 is equal to 8/12 because I didn't actually change the amount that I shaded in. It's still the exact same as it was in the beginning. Now once again, we have more parts that are shaded in and more parts total in the entire area model. But if we look at this part right here compared to this part right here, we could see that this one is much larger. The 1/3 is much larger than the 1/12. So that's why they're still equivalent, because even though there's more parts shaded and more parts total in the diagram, the parts are smaller. So they're still equivalent. So to show this with multiplication, we're going to have 2/3 equal to, and we need to see what do we multiply 2 by in order to get to 8. And so if I think in my head, well, 2 times 4 is 8, And I'm going to multiply the numerator and the denominator by the same thing, 3 times 4. And so I get 2 times 4 equals 8, 3 times 4 equals 12. And I checked and I showed with the area model and multiplication that 2/3 is in fact equal to 8/12. So that's kind of connecting it to our last couple lessons with using the area model. Let's take a look at one more problem that involves the area model, but uses a little bit more multiplication to show this equivalence. So zoom out here. Make sure I got all the words in there. Alright, that should work. So before I even start my area model, using my knowledge of showing equivalence with multiplication, I could look at this first problem and see that 3/4 is equal to, if I multiply the numerator by 2 and the denominator by 2, I know 3 times 2 is 6 and 4 times 2 is 8. So I already know to check with multiplication that these two are indeed equivalent. So let's show that with an area model. Oh, that's pretty lopsided area model there. I'm going to redraw that one. Let's see, I'm going to start with a rectangle here. Okay, and so I'm going to start with 3/4. I'm going to shade in 3 of them. And then I'm going to partition it in half. Oops. And I can see that I went from 3/4 to 1, 2, 3, 4, 5, 6 out of 8. So 6 parts are shaded in, 8 parts total. So I've checked 2 ways that those fractions are indeed equivalent. So moving on to the next problem, you might have already figured out that since 6/8 is equal to 3/4, then there's probably no way that 6/12 is also equal to 3/4, because 12ths are going to be a lot smaller than 8ths, and there's still 6 of them. But we're going to go ahead and check anyway and show why this fraction is not indeed equivalent. So if we took 3/4, and our end goal is we want to get to 6/12, we think, well, what do we need to multiply 3 by to get it to equal 6? And well, that's 2. And then we think, what do we need to multiply 4 by to get to 12? And that is 3. And so since we've multiplied the numerator and the denominator by different numbers, we know that these two fractions are not equivalent. And if we were to draw tape diagrams for both of these, well, for 3/4 to start out with here, let's do 3/4 first. And if we shaded in 3 of the 4 equal parts, oops, I gotta make sure that this is completely closed here. 3 of the 4 equal parts. No matter how we split it horizontally, there's no way that we can get 6 equal pieces shaded in and 12 pieces total in the entire area model. So if we were to split it in half to get 6 pieces shaded in, 1, 2, 3, 4, 5, 6. We don't have 12 total pieces in the area model, we have 8. But if we also made our 12 equal pieces, oops, I'm going to try that one more time here. If we made our 12 equal pieces, now we have 12, you can see that there's 9 pieces shaded in. So there's no way that we can show that 3/4 is equal to 6/12, so they are not equivalent. So the last problem we're looking at here, this one's going to be using exclusively the multiplication method that we've been looking at today. And problem 4 here asks us to use multiplication to find an equivalent fraction for 2/5. So we know that if we can find an equivalent fraction for any fraction, as long as we multiply the numerator, the top number, and the denominator, the bottom number, by the same number. So one way we could do it is we could multiply the top and the bottom by 2. So 2 times 2 is 4, 5 times 2 is 10, so 4/10 is an equivalent fraction. And we could just keep going, as long as we multiply the numerator and the denominator by the same number. For example, if we wanted to multiply the numerator and the denominator by 3, we would get 6/15. So that is also an equivalent fraction to 2/5. So really, if we wanted to, we could even multiply it by 100. As long as they're the same on the top, we're multiplying them by the same number on the top and bottom, so we would get 200 5/100ths is the same as 2/5. So hopefully you're able to see how easy it is to use multiplication to find equivalent fractions. And you should be able to solve any of the problems in the lesson 7 and 8 problem set, but if you get stuck on anything, feel free to come back and rewatch the video.